So these last few projects, they are going to be simpler ones. So by simpler, I don't mean the projects are going to be very small or something. I mean that they are going to be a bit more elegant. And why simpler, when I mean is like right now what we are going to do, we have always used our input as either an image or a text, right? This time the whole thing is going to change, and our input is going to be this time an audio. So yes, you guessed it right. If you guessed it, we are going to be on this project, we are going to be working on speech to text. Before we work on this like text OCR, this is also a very project which is like very complicated, right? So whenever models have been made, a lot of convolution 1D models have been made and built on it so that the whole thing can work. Even then it does not work that properly, right? So what has been done is basically they have already introduced us with some libraries. So these are the libraries that we can use to actually run speech to text easily. So what I am going to do is basically go very quickly over how this whole process works so that now we can run the speech to text. So let us talk about the process. So the very first thing that happens is you need to understand what actually audio waves are. What is happening basically. So you have audio as the input, right? So when you say audio, it will be either .wav file, wav file, or mp3 file or something like that, right? So what this basically means is these are, if you think about it, these are analog signals. So the very first thing that happens is basically these analog signals get converted into digital signals. Now all of this, how this is happening, you can go and Google it. See, this is a very easy thing, okay? So how this conversion happens, you can easily Google and you will be able to understand how this works, okay? So first what happens is these analog signals are converted into digital signals. Then some features are extracted, some cleaning has been done, some pre-processing and everything that is done. And then what happens after that is basically these are next converted into spectrograms. So what are spectrograms? So spectrograms are basically 2D graphs, and these graphs are basically a plot of time versus frequency. So time versus frequency of what? So this is basically a spectrogram of time versus frequency of the audio file, okay? So this is what basically the whole thing is. So it gets converted into spectrograms. Now there are a lot of things you can go, there are a lot of libraries which help conversion pretty fast, so you can go there and understand the whole thing also. But the whole point of this is basically it converts time spectrograms, it converts the audio files into spectrograms. Once you have the spectrograms, right, you can create a convolution 1D model. The whole point why is this 1D, if you think about these signals, right, these signals, they are in this format. So these signals, the only thing that they have is one dimension, just the height. There is nothing else that you can do about creating these signals, okay? The only thing that is the height. So hence we will be using convolution 1Ds along with RNNs to create this. So the way in which this has been done is these are the basic simple things. Other than that, there are models to understand the phonetic ways of speaking. Not just that, able to understand accents, identify vulgarity, profanity. I mean, there are a lot of things if you look into it, and these services, they are either related to IBM or Google. So Google speech recognition and IBM's cloud Watson recognition and everything. So these are some of the best models. They provide some of the best models when you have this speech recognition part, all right? So this is just a basic understanding of how speech to text works. What we are going to do right now is basically we are going to go over the notebook and we are going to understand how this is happening in real life. So the very first thing, see, again you can do this in real life, I wouldn't say you cannot. So there is even a blog post. This blog post is on Analytics Vidya, if you want to know. So there is this blog post on Analytics Vidya, and they teach about speech to text, but they train the whole model from scratch. So if you want, you can go there and understand as well, but the point is, see, even then you won't be able to get the best results. To get the best results, it is always nice to use a library in such cases. All right, so how do we start? We start with installing speech recognition PyDub. Okay, so these are two things that we will be installing. So you start with installation. Since both of these are already installed in my my base system, my environment, so it will show requirements already satisfied. Next, I'll be importing speech recognition, right? I am going to call my file name. So my file name is audio123.wav. Okay, so you can have different file names, whatever, you can change the file name. You can have any wav file and you can use that as a file name. Okay, so I have this already in my system. So if you look here, audio123.wav, this is the file, so it is already there, so this is not a problem. Next, I am going to call my speech recognition and give it a variable. Okay, so I am making an object for the speech recognition. So when you have this speech recognition application, right, when you have this whole package, what happens is it makes things very easy, so you don't have to worry about a lot of things. Here you just have to call the audio file as source, and then you have to just so there are a lot of functions even in speech recognition. So it has recognize Google, recognize Amazon, recognize Watson and other things. Okay, so these are different they will be using different models. So here we will be using Google's recognition model, speech recognition model. Okay, so one thing that you have to know is, if you are running these models, right, you have to make sure that all the audios are like less than 1 minute. The reason why is because Google just allows them to run for 1 minute and no more than that. Okay, so you can make sure of that, or to overcome this problem also, I have here a solution. But let us first look here. So it is running. Obviously it takes some time because it will first get send a signal to Google connection, and then it will come back. So this takes some time, obviously bear with me. So this, while this is happening, I can say easily about this. So this is basically a very simple file. So here you can see these are the outputs. So if you will go and read through this, right, you will be able to understand this is like very simple, and there will still be a few mistakes. All right, it's not that it will give you perfectly correct answers, there will be a mistakes. So in that case, what you can do is you can run your grammar correction, spelling correction and other things. Here what we are going to do is we are going to understand how we can get or understand work with large audio transcription. Okay, so when I talk about large audio transcriptions, right, I mean audio files which are greater than 1 minute. So when it is less than 1 minute, it is easy to understand and work with. But if it becomes greater than 1 minute, but you still need to find the speech to text recognition, in that what can you do? So in that there is a library called PyDub. So PyDub, what this does is basically it has an audio segment. So in audio segment itself also it has something known as split on second. Okay, so if you will see here, split on silence, sorry, not second, I'm so sorry about that, split on silence. So what split on silence does is basically, see, when you are speaking, right, when you are speaking anything, when you are working on anything, you might know that sometimes after a few phrases, every person who is talking takes a break. Okay, so there is a very silent pause. So to understand this, what they have done is basically, what we will be doing is basically we will be using kind of a trick. So what will happen is, firstly we'll be importing PyDub and we'll be loading our data file inside PyDub. Okay, so PyDub audio segment, we'll be loading it using the audio segment function. We'll be loading the sound. Once that has been loaded, what we are going to do is we are going to split it on silence. So that means whenever there is a pause, even for a very brief moment, we will split the audio. So we'll split it in such a way so that each audio file is less than a minute now. So if you have, so this is one big audio file, this is more than 1 minute, and if it gets split into different parts based on where the pauses are, in that case what will happen is you will get all the audios, but they will be in chunks, and these audio files, these files can later be used. How can they be used? They can later be used to create speech to text, but for a very for a very long audio file. Okay, audio file. So this can be used for a very long audio file in that case. So now let us talk about, so while this is running, let me explain how this is happening. So what happens is you are first loading the audio segment from WAV. Okay, this is using your PyDub. Once you have loaded that, you have to pass it on split on silence. Now these values, minimum silence, silence threshold, keep silence, these are different values, and you have to adjust that based on your audio recording. Okay, so it will not do it on its own, which is a bad thing, but yeah, you will have to adjust it based on the requirement. So sometimes the silences may be long, sometimes the silences will be very brief, sometimes during silence the decibel level, the loudness level will be different. So that you have to make sure. Once that has been created, what it will do is it will create a folder called audio chunks. Inside audio chunks, what it will do is it will save all these different files that have been created. Once that is done, what it will go through each and every chunk file, and for each and every chunk file it will go for a recognize Google, right? And that can be done. So you can see here, this is the output. So it broke it down into 10 chunk files. So the full text is basically you can read here. So this is, I am going to say again, this is not going to be the most perfect way, because this is a short term trick. If you want to make it in the most perfect way, if you want more than 1 minute speech to text translations and corrections in that way, what you can do is basically you can, in this case, if you want it, you can basically go and download and actually pay for Google services. In that case you will get speech to text for longer audio. Okay, so that is it. This was a very small elegant kind of project, but I wanted to add another form of input to it, so you can understand there are different forms and they can work together. So that is it. So that was the whole motive of it, and speech to text is used actually a lot. So I hope that makes it easier. It is used in Google Assistants, Amazon Alexa, Echo and other things, right? You all know it better than me. So that is it. I hope you understand the video. If you want to share your journeys, if you want to contact me, if you have some doubts, this is here my LinkedIn profile. Okay, so do text me, do share me, suggest me different stories, maybe advise me on how I could make better videos and stuff. So that is it. I hope you enjoyed the video and keep learning.